Guys, so over here I'm going to be teaching you how to do this project, the machine learning linear regression one, the basic one. Okay, the code's already been given to you about it. You can even do your own project if you want. Okay, so we have to basically predict the percentage mark the student is expected to score upon the numbers of they studied. Okay, so basically they've already given you the file URL over here, and you can just directly, and you can even basically just do this. I have to basically uploaded the file by copy pasting the path first and then the file name in and saving it as a comma separated value Excel file. And whenever you're uploading it on Jupyter app, always put the R here. In Jupyter notebooks, you don't need to. Okay, we first see the head, the 10 rows over here. Here they are. There are 2.5 hours, scores are 21, and 8.3 is 81. Okay, so we describe our relationship over here. Okay, all you have to do is just run these codes basically. So, and you have to only import libraries because Python makes machine learning and prediction very easy because it already has libraries for all the code stored inside. And we splitted all of the data over here between the training and testing, between 0.2 test size and a random state of 0. Okay, and we train the data over here using linear model linear regression. And as regression equals linear regression, we basically make our regressor. We create a variable called regressor and equal it to linear regression, meaning basically we are going to basically train the data after this by using regressor because it already contains linear regression inside. And then we use regressor fit xtrain, right? We train the data using this, and now data and print if it's trained. Now the data has been trained, so thus we also may ensure that training complete. We now plot a regression line to see how well of a perfect fit it is, and we can say that it is quite near to a perfect fit. Remember, machine learning also isn't 100% accurate. It's only 80% to 90% accuracy, and it's very helpful to people. Why? Because example, if I basically am selling something and I use a machine learning model to analyze the data of how other people have sold the same thing, it will still give me a better outlook. Example, if it gives me a zero point 0.8 variable per 8% prediction, that means if I sell this thing, it's an 80% chance it will be sold. And if it gives me 0.2% predictor, then that proves that there's a 20% chance it will be sold. And if I have an 80% chance of selling the thing, then I will want to invest all the cost of setting up my business and the sales point and everything to sell it. If I have a 20% chance of it being sold, then I won't, because it gives me the estimation, so I don't have to put in all that effort and hard work to do something if I already know that it's going to be, if it has a chance of being successful or not. That's what machine learning is very handy for, and we need it nowadays with the uncertainty living in our times. So we're going to be making a prediction. This one is the prediction we've made of the X test, and we basically equaled it to Y predictor, predicting Y of the X test. Yeah. Basically, just showing the number of hours increasing over here. That's what X is, right? The number of hours that will keep increasing. But now that we want to predict 9.25 hours a day, that what score will be achieved if we basically study 9.25 hours a day. So you basically you create a variable hours, you equal it to 9.25, and you make sure to add these double brackets because we need to show it as basically a two-dimensional array, because these predictors only read two-dimensional arrays. They don't read single dimensional. Because example, if once I all the code's written and I put this in and I run it, it's showing me this. But if I do this, if I remove this example, this is what it will do, because you have to show the number of hours as two-dimensional in order to ensure that the machine learning libraries read it. Okay, this is the main task. The rest is already given to you, and make sure to give your own evaluation of the model. I'm not going to show you that because that's something you have to do on your own. Okay, and that will be all, folks.